Fossils are more widespread than you may realize. As a boy, Charles Darwin used to spend a lot of time in the outdoors. He was an avid hunter and fisherman. It may be because of that background that when he went to college, he left medical studies, but enthusiastically embraced biology and then geology. In a famous letter to his sister in April 1834, he wrote, "There is nothing like geology. The pleasure of the first day's partridge shooting or the first day's hunting cannot be compared to finding a fine group of fossil bones which tell their story of former times with almost a living tongue." That's what happens. An interest in the outdoors and collecting becomes a passion for geology and paleontology. Could that happen to you? I hope so, at least a little. And then, who knows? Fossil collecting is something that everyone can do. It's a great way to get out, to enjoy nature, and to learn about the geology around you. With a little bit of knowledge about what fossils are, and we talked about that in the previous lecture, and a little insight into the geologic occurrences of fossils, you can be collecting in no time. After all, humans have been collecting, wondering about, and enjoying fossils for most of recorded history. Even before that, Neanderthals used to place fossils around burial sites. The reason, of course, is unknown, but it certainly is symbolic of the immortality of preservation. It took a long time for people to appreciate exactly what fossils were and why they were important. Initially, people tried to explain fossils with legends. Ammonites were called snake stones in Ireland and thought to be the snakes driven away by St. Patrick. Here is a snake stone. Can you imagine its head coming out of the shell? This is a small ammonite, a relative of squid. The star-like forms of crinoids and corals were called star stones and believed to have fallen from the sky. Here's a coral. Can you see the stars? These, of course, are colonial animals. Aristotle suggested that fossil fish were animals that had lived in the past, but his theory was that they had swam in cracks in rocks and at some point were stranded there. In the mid-1600s, Niccolò Steno, the founder of modern stratigraphy, recognized that fossil shark's teeth were the remnants of sharks, very similar to those of today. But prior to his studies, people considered shark's teeth to be the tongues of dragons or snakes. Now we know that fossils are evidence of past life, whether it's a part of the animal or evidence that the animal existed. This evidence is preserved in the rock record. Fossil collecting can enable you to reconstruct what animals or plants lived in the past. It's a lot of fun. It's really informative, and I would argue it's pretty exciting when you come across a well-preserved fossil. Also, now that you have learned about sediments, sedimentary environments, and types of fossils that are preserved, it's not a difficult process to go do some pretty good fossil collecting. What's different is you'll spend more time turning over the rocks you see, and maybe more time scrambling up and down slopes, since that's where fossils are more likely to have come to the surface. It's also important to know about collecting, access to collecting areas, and ownership, so fossil hunting is an advanced sort of rock collecting. One very famous Tyrannosaur fossil is named Sue. It is by several measures the most well-preserved Tyrannosaurus in the world. A lot of people also know that it is the most expensive dinosaur ever purchased, with a purchase price of over $8 million. But its history is, to say the least, complicated. An award-winning documentary about it called Dinosaur 13 was made in 2014. A group of scientists from a private firm had obtained permission to collect fossils in western South Dakota. The story goes that the collecting season was almost over and several samples of dinosaurs had been collected, and the group was close to wrapping up. A flat tire on one of the vehicles resulted in the group splitting up and one staying behind with the car with a flat. That paleontologist, Sue Hendrickson, decided to do some checking around in places the group had not studied, and she found some of the remains of the Tyrannosaur. It was recognized quickly that this was a great find. The skeleton was excavated and taken back to the group's lab. Once word got out how special the Tyrannosaur fossil was, people became interested. The landowner, who had given them permission to collect, raised questions about the process. Additional complications included the fact that the Tyrannosaur was found on tribal lands. The Department of the Interior claimed that it was land under their trust. So to suffice it to say, discussions ensued. These discussions ultimately resulted in the FBI and South Dakota National Guard raiding the labs where the fossil was being analyzed, and a long political and legal battle began. So the moral of the story is to make sure that when you collect fossils, you're doing it on land where you have legal access and have permission to collect. They are not the same thing. In the U.S. legal system, contrary to common perception, all rocks, minerals, and fossils are treated as being owned or possessed by some person or entity. Of course, if you own the land, you are allowed to keep fossils you might collect. If you don't own the property, you have to check with who does and what you might need to do to gain permission to collect. One way to ensure that your collecting is legal is to ask either private landowners or public land managers. Many places, especially federal lands, restrict fossil collecting to invertebrates. You're often not allowed to collect vertebrate fossils. National parks in general do not allow the collection of fossils at all. But in the case of national forests, collecting invertebrate fossils is sometimes possible. Make sure you check, and if required, get a permit. In many states, there are designated fossil hunting localities. There are designated state preserves in New Jersey, Ohio, Maryland, Texas, Pennsylvania, California, and Colorado, where you can collect. There are frequently restrictions based on what you're going to do with your fossils. If the fossils you collect are for personal, non-commercial use, you can keep them. Sometimes tensions can run a little high when it comes to fossil collection if the sale of those fossils is involved. Not only do you encounter ownership issues, but there's also the question of the scientific use of the fossils. There are a variety of famous and wealthy individuals who collect fossils. On face value, that's great. An interest in fossils is completely understandable, but sometimes sales to private buyers will bypass opportunities for scientific analysis. There are a lot of fossils in private hands that have never been studied by scientists. That's viewed as problematic by the scientific community. Yes, it's certainly true that in most cases, fossils in private hands do not contribute to the broader body of scientific knowledge. But in a rare case, it would be handy to have a paleontologist study it. So to sum up, before you go fossil collecting, you're going to find out who owns the land, whether or not fossil collecting is permitted, and if you need a permit. Checking beforehand may save you a lot of headaches. If you are collecting fossils, let scientists know about it. Your state geologic survey is a good place to start when you want to let someone know what you found. They might also give you some advice about what you found and where you can do additional collecting. A rule of thumb is that if you find something but don't know what it is, please show it to a scientist. When getting ready for fossil collecting, you go through the same organizational procedures as with any fieldwork. You'll need water, multiple ways of locating yourself, maps, GPS, cell phone, your field book, and a camera. Specifically for fossil hunting, you need tools to help you excavate: hammer, pick, shovel, smaller tools to pick away matrix or chisel apart bedding planes, sample bags, something to wrap your fossils in, and marking pens to label your specimens. A camera is really important for fossil collecting. You want to take pictures of the outcrop right where you found the fossils. Frequently, You will encounter fossils you won't be able to remove without damaging, so a picture will provide a record of the important finds. I can't emphasize enough that there are some outcrops that you shouldn't take a hammer to. There is nothing more irritating than knowing the location of a great fossil only to return to it with students to find that someone's destroyed it in an attempt to remove it. A photo is a great way to collect fossils. At some fossil localities, weathering and erosion will separate the fossils from the rocks that they occur in. When you collect fossils along a river cut or a wave cut, most of the collecting is done at the bottom of the bank where the wave action or running water and rain will loosen up the rock or sediment that contains the fossil. If the fossil is made out of resistant material, it will fall out of the sediment or rock in fairly good shape. At other localities, fossils are still embedded in the geologic unit. In those cases, you have to remove the rock material together with the fossil. I have to warn you, it's a rookie mistake to try and trim the fossil out of the rock in the field. More fossils get damaged that way. Take a chunk of the rock that has the fossil in it. You can do the detail trimming, called preparation, back at home. This shark tooth was left in the rock, but polished for presentation. Can you see the cracks in it? It certainly would have been broken if you tried to remove it. Here the rock becomes part of the display as well as the fossil. At home you will have different tools, a sink to work in, time and comfortable working conditions. The finished or prepared fossils will be much better. Before you go fossil hunting, let someone know where you will be and when you'll be there. Maybe leave both a map and a description of the geologic units you're looking for. You should always do field work with someone else for a number of reasons. I've outlined those in Lecture 3. But on top of that, leaving a description of your destination and collecting plans is just an easy thing to do to ensure that you can be located in an emergency. Again, I understand that cell phones can be very handy for a wide variety of needs, but I have never learned to trust them, mainly because I've spent a lot of time in places that cell phones don't have coverage. Okay, you're ready. You have all the stuff that you need for fieldwork. You've got a friend who is also interested in collecting fossils, and you've let people know where you'll be. The big question is, where do you go? It's a good question. Finding fossil localities isn't always easy. As I mentioned, in many states, there are designated fossil hunting localities. Here's a map of a few of the good ones in the U.S. Calvert Cliffs in Maryland is a place where you can walk along the Chesapeake Bay and collect shark's teeth. In Freehold, New Jersey, an hour drive from New York City, the Big Brook fossil locality exposes Cretaceous age shark teeth and mosasaur teeth. In Ohio, Cedar Creek State Park in Waynesville has Ordovician-aged trilobites and brachiopods that you can collect. The list goes on. For more locations to visit, try geologic organizations in your state. These might include the State Geologic Survey, a local geologic society, or a university nearby. Some geologic organizations, like the Geological Society of Minnesota, lead field trips to well-known collecting sites, and some lesser-known places. You can also check out opportunities to collect fossils with the help of academics or professional fossil guides. There are some programs run by private firms and universities where you can sign up and participate in a fossil excavation. In most cases, these are large-scale and long-standing enterprises that will involve very careful preservation of vertebrate fossils. You get a great introduction to the science of paleontology, but you don't get to keep the fossils. If keeping fossils is not important to you, these can be great experiences. There are also commercial fossil expeditions where you do keep fossils, and all of them can be found pretty easily on the web. In Wyoming, there are guides that will take you to the famous 18-inch layer of the Green River Formation. In Florida, guides will help you screen for mammoth teeth buried in the river sediments of the Peace River. In Montana's Hell Creek Formation, you can look for dinosaur bones. In Oklahoma, you can collect trilobites. The right fossil hunting guide will ensure your safety, your permit to collect, and they'll identify the fossils you find. In many cases, the guides will have an association with a university. These are good ones to seek out. If you happen to find an important fossil, they will have you turn it over to the scientific community. They tell you that in advance, but frequently they might have a nice fossil that they can trade for yours. Overwhelmingly, the fossils collected at these more commercial sites are ones you can keep, and the guide will make sure that collecting is done thoughtfully and conscientiously. You can find fossil expedition and guides on the web. Blogs and personal websites will provide some indication of how good the fossil hunting experience was. Another way to find guides is to go to a mineral, gem, and fossil show. Look around these exhibits. If you see a fossil that interests you, the seller might know if guides can lead you to collection sites. In many cases, the person displaying and selling the fossils is the person that can take you. Start a conversation. Ask questions. Learn about the fossil locality, and the collector. You may end up in some interesting places with some interesting fossils. In the beginning, though, most people just want to go out and look for fossils. Maybe if they enjoy their initial experience, they will go on a guided expedition later. But for now, say you just want to look around. That's how most people get started. So where do you go? It turns out that there is a lot of literature about local geologic exposures. Many states will have either websites or brochures about collecting fossils in the state. Localities might be a designated park, but they can also be just a road cut, a place where highway excavations have exposed fossiliferous rocks. There is also a series of books called Roadside Geology. These books explain the geology that you see while driving along roads in individual states. They also point out where fossils can be found along the roadside. There are dozens of roadside geology type books, or something like them, that are commercially available guides to the local geology, and they will indicate where fossils can be found. I have to say here that you do have to proceed with a little bit of caution when using fossil pamphlets and roadside guides. Sometimes access and permission to collect changes since the publication of a reference you might have. It might be handy to see if you're still allowed to collect at sites you've read about. It also is important to always remember that roadside collecting means you will be close to traffic. Make sure your car is off the road, that you and your car are visible to oncoming traffic. You also have to be sure that it's legal to stop on that particular road. You don't want the hassle of a citation. Always be sure that you are very careful to avoid interactions with moving vehicles. Please, please be safe along roadsides. It is really fun to collect fossils, and it's great to get excited about them, but safety first always. If it looks safe and it looks like the right type of rocks, then walk along the base of the outcrop. What you're looking for is fossils that may have eroded out of the outcrop during rainstorms. An especially good time to check them out is after a rainstorm or soon after spring snowmelt. But a recent rain also makes rocks slippery. In South Dakota, there's a bentonite volcanic ash that holds so much water and gets so very slippery. On one field trip, a few of the students simply became obsessed with climbing up the slippery slope. Yes, there was the Teddy Roosevelt Petrified Forest to see on the other side, but the end result was a mud covering from head to boot. Okay, so you've collected anything that's washed out and the outcrop seems safe. Walk up a little bit to see if any fossils are loose on the slope or still embedded in the rocks. Field safety is a must. For example, be careful of shifting rocks around as you search. Rocks are hard. You don't want to dislodge anything that's big enough to hurt you or your field partner. You also don't want to get knocked off balance. You also have to remember that there can be critters who have made a happy home under rocks and in spaces between them. Some of them don't like to be disturbed. Don't stick your hand into cracks. When you're moving rocks, use your hammer, not your hand. Keep an eye out for fossils and living things. So now we're looking at the rocks. It turns out that a lot of times you can predict from the rock type what you might find, especially if you know the age of the rock. I bet you can tell me right now what fossils go with what rock type. You want to try? Say you're at an outcrop of shale. Slopes will be gentle and there will be loose sediment on the slope. Sometimes the upper layer of material will crumble beneath your feet. It might be calcareous, it might not be. Where is a shale deposited? Well, it's a fine-grained sediment, so that means fairly low energy. What would have lived in that environment? Most commonly, shales, especially calcareous shales, are deposited in deeper water of seas that covered the continental U.S. Depending on age of the rock, you might find trilobites, brachiopods, or mollusks. These Devonian-age brachiopods from Illinois are hard enough to survive being washed out as small shells. But these Cretaceous pecten shells had to be cleaned pretty carefully. Trilobites are an arthropod that periodically shed its outer hard part. Often those discarded parts are found on sediment bedding plains. You'll have to split the shale layers open to see if there's anything in it. Look at this bedding plane. These are Devonian-aged trilobite remains from upstate New York. If the shale is Cretaceous age and deposited in the seaway that existed from Texas up to Winnipeg, you might find shark's teeth, fish bones, or the shells of bivalves. All of those fossils I just mentioned, trilobites and brachiopods from the Paleozoic, and shark's teeth and fossil fish bones from the Mesozoic, are common fossils found throughout the United States. Are all shales the same? Of course not. I've mentioned the Green River Shale, which is a black shale that was deposited in anoxic lake environments. In black shales, you can find fish bones, leaves, insects, and even vertebrates. But usually, black shale fossil localities are well known. Here's an early Mesozoic starfish from Italy that was preserved in a black shale. How about sandstone? What would you find in there? Well, think about sandstone. It is a high-energy environment where sand has been transported and deposited by fairly rapidly moving wind, rivers, or waves. Wind-blown sands are notoriously scarce of fossils. If you encounter a sandstone, enjoy the intricate sedimentary structures and the sedimentology of the ultra-pure sands. And don't worry about fossils. Rivers are also high energy. Yet you do find fossils of animals that have been rapidly buried. The complication is that water action will destroy fragile components and scatter the more robust ones. Of course, dinosaur fossils are found in association with river deposits in the West. When studying river sediments, remember that in most cases you can't collect vertebrate fossils. The exception is teeth or disarticulated bones of mammoths or horses that show up in gravel pits or reworked river deposits like the Peace River in Florida. Those are great fun to find and collect. Most of the fossils that you find in sandstones are associated with shorelines. Again, throughout North America, the Paleozoic was a time of shallow seas with changing shoreline positions. In a lot of places, you can collect fossils in finer grained sandstones or siltstones. The fossils might include brachiopods, trilobites, and an occasional fish fossil. Here are Miocene-aged fish from Sharktooth Hill in California, preserved in a fine sand. More frequently, you find trace fossils in fine sands. Again, these are tracks or trails or impressions left behind long ago. Let's try one more. Say your outcrop is a limestone. In a lot of cases, the limestone will be resistant, especially in drier portions of the country. So that means in a lot of cases, limestones are cliff formers. Slopes will be steep and the rocks will be resistant. Be careful on steep slopes. What environment did the limestone form in? Shallow seas, right? Envision your favorite coral reef today. In a lot of cases, that's where limestones were deposited in the past. So what will you find? The short answer is a lot of things. Brachiopods, trilobites, and coral of all varieties depending on the age of the rock. Here's a group of stromatolite towers. This is a 500 million-year-old fossil found in a fieldstone. Some sandy limestones will have well-preserved algal fossils called stromatolites. In Precambrian and Cambrian rocks, stromatolites make up a significant portion of the limestones and are considered to be one of the main sources of free oxygen in our atmosphere. Limestones can also hold cephalopods and ammonites, shelled relatives of octopus and squid. Here's an example of an early Paleozoic cephalopod from Winnipeg, Canada. It came out of a rock quarry, and so the rock quarry sliced these things in half. You can see it beginning here and extending to here. It was a long, thin shell. The list goes on. Now you know what you're looking for. The next question is, what do you actually see? The answer is decidedly not anything that looks like what you've seen in books. There are lots of fossils, but only a few that are what are called a trophy fossil. The fossils you see in books are both rare and painstakingly prepared before being photographed. That's not what you're going to find in the field. Fossil collectors frequently use the term fossil hunting to describe the locating and collecting of fossils. I am not a hunter and I know little about hunting, but I get the point of the analogy. It takes care and preparation and knowledge and commitment to find fossils. What you want to look for are objects that look different from the surrounding rock, a different color, a different shape, or a different way the rock is broken. Fossils are preserved in every orientation, so you might be looking at just the edge of the fossil. Fossils get folded up or broken or squished during deposition. You have to be patient. You have to get your eye in. For some people, it will come quickly. For others, it takes time. It definitely helps to have seen what fossils look like in the field rather than pictures from a textbook. Ultimately, it comes down to observing thoughtfully rather than just looking. I think most people can do it if they try. So what do you do when you see a fossil? Well, if it's loose, you pick it up. Decide what it is and put it in the sample bag. You might wrap it up in tissue or a napkin so it doesn't break. If it's in a limestone, you have to make some decisions. Limestone, because it is hard, is difficult to collect fossils from, especially when you're just beginning. The tendency is to try and remove only the fossil from the outcrop. That's a mistake. You should either take photos and leave the fossil there, or take the fossil with a great deal of matrix around it. When you get back home, you can use a variety of tools. Brushes are perfect for removing a small amount of material. Small picks, like a dental pick, can be used to scrape away more resistant rock. A little bit of water can help soften up the process and may make removal easier. A Dremel type tool will help you physically remove the surrounding matrix. You can also, if you want, resort to a little bit more aggressive practices. I can remove some of this matrix from the cephalopod. I don't want to do too much more. Some folks use a weak acid like vinegar to clean up the fossil by dissolving the cement in the matrix. That's the process called preparation. You may also need a little epoxy if your fossil broke somewhere along the line. But in most cases, it really is just fine if you just lay out your fossils on a board. And remember to label location you collected at and when you collected it. So that's fossil collecting. Just remember, Stay safe and be careful about where you collect and get permission if it's needed. If you think about what you're doing and what it means in terms of geologic history, I think you'll enjoy fossil hunting. Even if the outcrop you're looking at turns out not to have fossils, that's okay. On the plus side, you're still outside and you are still doing geology. What's better than that? As many fossil collectors say, good hunting.